Hello everyone. Good morning, good afternoon, good evening. Today we are going to learn fabric path VPC plus scenario. So in order to understand the fabric path, we have to see the scenario, which is how the traffic moves, when we have a fabric path and with VPC, right? So this is my scenario one. Fabric path with VPC, and second one is fabric path with VPC plus. So let's understand, for the scenario one, right? So let's suppose host A wants to talk to host B, right? And it sends a packet. So, let me write here type 1. Source A wants to talk to host B, right? So what it will be doing, it will send a packet. Once a packet reaches to the switch one will, because this is your fabric path, so it will encapsulate it. So my outer source ID will be switch 1, outer destination address will be switch 3, right? Because the packet has taken this part, right? My original source address will be A and destination address will be MAC B. Now once a packet is encapsulated, it will be forwarded to the switch 3, right? Now let's suppose, same time the host A wants to talk to host B for some another type of traffic, and because this is a port channel, and due to the load port channel hash algorithm, it selected this path, right? Now once for traffic type 2, okay, now once a traffic reaches to the switch 2, this is my Ethernet frame, right? Source switch ID will be S2, right? Source switch ID will be S2 and destination switch ID will be S3, and from here the packet receives here. Now the switch 3 will have that MAC A is reachable via S1, MAC A is reachable via S2 also. So if this host replies to whom switch 1 or switch 2, this switch 3 will send a packet, right? So I mean this can cause a MAC flap issue, right? Now if I convert this, this problem can be resolved via configuring a VPC plus, right? So in the VPC plus, what happens, we configure another virtual switch ID under a VPC domain, right? So let's suppose I configured a virtual switch ID of these two as a switch 4. Now my switch 1 or switch 2 will be treated as a switch 4, okay, right? Now so for a switch 3, switch 1 and switch 2 will be seen as a single switch, okay. Now the MAC A and MAC B will be reachable via switch 4 only, right? Now the switch 3 will reply to switch 4. Now either this packet reaches here or this packet reaches here, right? It doesn't matter. Now because S1 has a VPC plus configured, and with the help of we using the technology of the VPC, it will send the traffic. So then in that case there will be no MAC flap issue. So this is the problem solved by VPC plus over VPC, okay. Now what is the VPC plus? VPC plus is just similar to VPC, right? Except some configuration changes. VPC plus require a virtual switch ID to be configured in the VPC domain apart from its unique switch ID, okay. All hosts which are behind the VPC plus will be identified by this virtual switch ID, and all other orphan port and single attached host will be identified or associated by its individual switch ID. The virtual switch ID is also distributed by ISS protocol to all other switches in the fabric path network. Okay, so if you want to configure the VPC plus switch ID, so what we will do under VPC domain, okay, we have to configure a fabric path switch ID like this. Fabric path switch ID. Okay, and all the VPC peer link must be configured with switch mode fabric path. Configured with switch port mode fabric path. So this is the configuration we have to do while configuring VPC plus into the fabric path domain. Now, what is the in the in the section 1 we have seen that in the every outer SA or outer DA we have a 3 field switch ID, subswitch ID, and port ID. Now, if there is a no VPC plus in the domain, this value is not going to participate. But if there is a VPC plus into the fabric path domain, so how it will be formed? So let's suppose host A is sending a packet. Now now this switch this is, let's suppose this is your switch ID 5. Okay, or this is this is not, this is your classical Ethernet. So let's suppose the traffic reaches here, and this is your switch ID 5. Now here the encapsulation is going to happen. Okay, now from here this is my source switch ID, this is my VPC port channel ID. So this is my VPC 10. So this is my 10, and this is the port ID. This is the logical number of the interface participating in the VPC port channel through which the packet is sourced or destined to. So this will be 2134. So from here it will be sent. Now let's suppose if the packet is sent here also, right? Because this is my VPC plus, so my source ID will be the same because I have configured a fabric path switch ID, right? Again, my VPC port channel 10 and my logical interface 2134, and from here the traffic will be forwarded. Okay, so the SID is used by the VPC peer to populate the outer SA source switch ID field in the Cisco fabric path frame originating from a VPC plus port channel. The subswitch ID identifies the originating VPC plus port channel, and the port ID is basically the logical interface of logical ID of the port, right? So switch ID, fabric path switch ID, subswitch ID, port channel interface, and port ID is the logical number of the interface participating in the VPC port channel. Okay, so this is how the frame is created when a traffic originates from a fabric path domain which is having a VPC plus configured. So now let's look the how the traffic flow into the VPC plus domain. Now here host A wants to talk to host B. Okay, now what happens? when a traffic is sent here, right? I mean, let's suppose, the host A wants to talk to host B and host A doesn't have a MAC address of host B. So what will happen at first space? Host A will send a ARP request for host B, right? Now, once the ARP request reaches to this switch, let's suppose this switch sends a packet to switch 1. Now what happens, and there is a rule in the VPC plus scenario. Each switch will announce its affinity towards tree 1 or a tree 2, right? So let's suppose S1 and S3 has announced its affinity to F tag 1, whereas switch 2 and switch 4 has announced its affinity to F tag 2, right? So switch 2 and switch 4 are participating for F tag 2 tree, whereas switch 1 and switch 3 are participating for switch 1, right? Sorry, F tag 1 tree, right? Now once this switch 1 has received this packet, okay, the MAC address of switch of host A is learned here, right? Let's suppose it has a SSID 100 configured. Here also SSID 200 is configured, right? And because this is a VPC plus, so CF SOE protocol works here, right? So with the help of CF SOE protocol, the MAC address is also learned here, right? Now the switch, because this is a broadcast packet, so switch 1 has announced its affinity for FT tag 1. Now switch 1 will encapsulate this packet, right? And it will send to switch 3, right? So what will be its a packet header? So this is my ARP request original. This will be my source, outer source address. This will be my outer destination address, outer source address. Okay. So source ID will be, let's suppose 100. I'm not using the subswitch ID and all those other things. Okay. FT tag will be 1. Okay. Right. And this is my broadcast. Okay. Now switch 1 will send this packet, right? Because this has a FT tag 1, and once the packet is received to switch 3 and switch 4, right? Switch 3 will accept this packet because it has a FT tag 1 associated it with. Switch 4 will discard this packet because switch 4 has announced its affinity to FT tag 2, right? Now once the S3 will receive this packet, right, it will decapsulate it, it will send it to access switch, and from the access switch the packet reaches to the host B. So the host B will the host B will be able to learn the host A MAC address. Now what happens? It will reply it. Okay, so let's see how it will replies it. So again, the rule is that switch 1 and switch 3 has announced this affinity to FT tag 1, and switch 2 and switch 4 has announced its affinity for FT tag 2. Now when the reply sends here, ARP reply, right? The ARP reply will be, let's suppose the ARP from the VPC port channel, the packet, this switch select the port, this path, and it reaches to S4. S4 has announced its affinity to FT tag 2. It will create a fabric path header. So let's suppose this is my ARP reply. My source will be this is my SSID 200. So this will be 200.20 dot, right? And this is my FT tag 2, and this is my unknown multicast address. Again, this will be sent here. The packet will reaches to switch 2 also. The packet will reaches to switch 1 also, because this unknown unicast has a mark of FT tag 2. So switch 1 will discard it, switch 2 will accept it, it will decapsulate it. Here, this switch 2 will learn the MAC address of B as a remote because of the conversational MAC address learning. Okay, and then this packet will be forwarded here, and from here this will be sent to our reply will be sent to host A. Okay, so this is how your your ARP request and ARP reply happens into the VPC plus fabric part domain. Now we have the host MAC address already, destination MAC address is already learned onto the switch 2 with the help of CFSOE. It will be learned here also as a remote. Now the host A can easily send a packet to host B. Okay. So thank you for watching the fabric part VPC plus. Thank you very much. Take care. Bye bye.